I got this kit a while ago from AliExpress and I never get a chance to build it up, so I'm planning to build it and show you the functionality of this kit and how handy it is sometimes. Hi guys, and welcome back to another video on my channel. This 5 pounds AliExpress kit is really handy, especially for those they don't have an oscilloscope, because it's capable to measure the frequencies. So let's build up and see how it's doing. This kit is really simple and really easy to build up. So we have a nice red PCB over here and involve just few resistors, some diodes, some capacitors, 2 transistors, variable capacitor. We have also crystal over here that has the frequency. And what I read on the PCB is doing also the crystal tester, so we can also measure the frequency of some crystals. So yeah, let's see all the parts that involve over here. And we have, as I say, resistors, diodes, this 7-segment display, but actually there is 8 because you have the dot as well. So you have 1, 2, 3, 4, 5, 6, 7, and plus the date is 8. So 8 segments displays are these ones, because you have the dot over there as well. So we have these ones. Then we have PIC microcontroller over here, which is the brain of all this device. We have a power jack over here. Then we have a pushy button, I think, when you press to start testing. I think these one are the where you can insert the crystal, or where you're gonna insert your connector to measure the frequency. Some other resistors over here which are loose. I need to measure to understand which one is which. I believe this one are the 1K, because the 1K we have 2, 4, 6, 8, 9 in total. So we have 2, 4, 6, 8, 9. So yeah, this one definitely are the 1K resistors. I can say we have the crystal over here. Few capacitors. I believe most of them they are 22 picofarads and 10 nanofarads and 100 nanofarads, I believe. And the 3 transistors. Yeah. So that's everything what involved on this one. So I believe I'm gonna start soldering this display, because I want to keep it flat on my solder mat over here, and then solder, because if I put all the parts, then it will gonna be not easy to keep this one flat on the PCB. So yeah, I'm going to insert all of these ones, solder them in place. You see, I can press it down against the table and I can solder them like that. They stay flat over there, you can see. Alright, so let's start with these ones and then we're gonna carry on with the other ones. So let's see if I can solder easy without flux, because this solder wire has a rosin core. Yeah, looks like it's working nice. So I'm gonna fast forward this part when I'm soldering this display. So I can see all the pins are soldered in place. Nice. So now we go with the resistors. So let me get the 1K resistors. We also let's measure one to make sure that are the 1K resistor, because sometimes the seller can include wrong resistors on the, yeah, so you can see it's 0.9000 ohms, so this mean is 1k resistor. So I'm gonna bring my PCB holder, and we can put the PCB over here and we can easily do this job. So I said that here are the 1k resistor, so I'm gonna insert all of them fast forward and then I'm gonna solder them, okay? So far 1k resistors and display it's soldered in place. I trim also the excess leads over there. So now we are going to finish all the resistance, but here I need to measure individually because I have 100k and 10k and 10k. So I have two 10k and 100k. So let's get a quick measurement on these resistors to see what they are. So let's start with this one. And this one is telling us that is 10k. So this one is one of the 10k. Let's see the next one. Next one is also 10k. And this one should be the 100k, right? Let's have a look. Yeah, this is 100k. Right, so let's put the 100k on the right place over there. And the 10k. Solder them in place. So this one is 100k, which it will gonna goes in here. Then we have the two 10k, which I say one should go up here and the other one just next to it over there. Okay, quick solder also to these ones. I will not fast forward this because it's just two resistors over there. So cleaning the tip. I'm using 300 degrees and BC2 tip, and the soldering station which I am using is YCS S1 with the T245 soldering tip, which really perform well. And if you are interested on this soldering station, check the link on the description down below. And we have this one done. Few excess leads over here to cut off. Right. Now I'm gonna say let me do the diodes. So for diodes, please pay attention to the polarity, because the diodes, they will not work if you install them backwards. Okay, so let's get these diodes in place, and I say pay attention to the polarity. You have a black line over here and you have the line on the PCB, so this one should goes over there and should go in that position. And we have the next ones just right next to it. There is three of them in this and one down here, so these three, they go in the same direction, all of them. And then we have the other one which goes with the line in that direction. Let's give a quick solder also to these ones. Okay, we have also the diodes installed, and now I'm gonna say that I'm going to the capacitors. So I say I have these 22 picofarads over here, but actually before soldering that one, I'm gonna solder the crystal to make sure that is in a position over there. And this one, you need to be quick, because if you heat up too long, you might can damage it. So let me do quick one leg, make sure it's staying straight over there on the PCB. And we are soldering also the other leak very quick, and also the cutter can damage it, so make sure when you cut you go straight down, don't put too much stress on the lid. So we have also that one done. Now we can go with these capacitors. They are 22 picofarads, all of them. So I have one there. The second 22 picofarads, it's next to it. The next 22 picofarads is just right here, and the last 22 picofarads should be, I can't see it, right, like usually. So did I have any extras? Because I can't see any other over here on the PCB. I can see just 3. So 1, 2, 3. Then 104, 102. I think I have one extra. So let's solder this one, and then we're gonna see how it's going to be the next ones. Then if you are interested on this PCB holder, also check the link on the description down below. I'm gonna put the link also to all my tools that I have here around, and I am using them. If you are interested, just check the links. Definitely there are going to be useful links down there on the description. And this is the last capacitor, solder. Let's give a cut to the excess leads. Alright, we have the capacitors in place. I think this one is not staying too much straight, so I can hit up one side and push it down. Now it's straight over there. I have another one that is not straight, this one over here. Now it's straight. Okay. So all sorted. This excess lead and this excess lead over here. Yeah. Alright, so we have just few parts left over here. So I'm gonna do this one is 102 and this one is 104. So 104 is just right here. But before these capacitors, let's install this socket. So the socket should sit over here if there is no bent pins. Right, so it's sitting there. I'm gonna hold it and I'm gonna do 2 pins because otherwise there is no option. So hold it tight to the PCB and you do the opposite corners, so one there and one here, and you can check to make sure it's flat to the PCB, and then easy to go to solder all the pins. Sorry for reflection. Here we go. We have soldered in place the socket for the brain of this device. Now we can go with this capacitor. So I say this one is 102, this one is 104. So 104 should go in there as the 104 capacitor, and then 102 is just there. That's 102 and 104. Let's quick solder them. As I say, it's an easy kit to put together and it's really useful and handy. You're gonna see at the end when I'm gonna run few tests on what this can do. Right, next I'm going to put the transistors. So we have here the 918. So 918 is over here. Then we have 914, so 914 is this one over here. Then we have the 7550, which is this one, which is going to be over here. Let's solder them quick. So that's also sorted. Excess leads, let's get them rid of them. And if my camera focus better, hello camera, yeah. Now I'm gonna say let's put the DC jack over there. Same, I'm gonna hold in place with my finger and we're gonna go to solder one pin. We solder the other ones, left over, another 2 pins. Next one, let's do the... Here is something that I would like to understand, because we have these 2 points where we can put things. Sorry for reflection. So I have here and I have here. So maybe this one comes here, the 3 things. But I need to see if they are connected to anything, because I can't see. Yeah, this pin is connected. So I have this pin connected. Yes, so I believe this one comes here, and I think there is same if you want to power separately, because you have positive, negative, and in should be the signal that measure. I'm gonna see, maybe I'm gonna prepare some of my own pins over there and put also there some pins, but until we get to that point, let's solder this variable capacitor over there, because with this one definitely we need to calibrate something. So let's hold with my finger underneath and give some solder over there. So that's one, and that's the second one. Yeah, looking good. Just a little bit to stay flat to the PCB. Now it's definitely flat. Yeah, it's flat to the PCB now. And the pushy button for testing, definitely. Let's give a quick solder also to the pushy button over there. And now let me try to find another one like that, this kind of connector, and add also there one. I managed to find on my stock some similar connectors. Yeah, so I can put the 4-pin over here, semi holding, and I'm gonna solder the pins while I'm holding, because otherwise it will gonna fall down. So let's solder one pin only. Let's make sure it stays straight. Yeah, just a bit bending in the other side like that. Yeah, I think we are straight now. Yeah. Let's put also the other one in the same method, holding, give one pin solder. I think I'm gonna solder the middle one. Go quick to check to make sure that you can solder straight. Is that straight now? Yeah. Let's solder also the other pins, and we should be alright. We should be ready to do a test to see if it's smoking or if it's working. What do you think? But first, I believe it's good to give a nice clean of this flux or rosin left over on the solder pins. So let me get some alcohol and brush, and we're gonna give a nice clean. So everything what's left is to insert our microcontroller over here, and that's inserted perfectly. Now I need to check the right connector over here, and to put between 5 and 9 volts and see what it's doing. So let's do also that one. So put your bets in, it will gonna work or it will gonna smoke. I really don't know, so let's find out. And before testing this device, let's have a look a bit on the description of this device to understand few things about it. So here it says that can measure frequencies between 1 Hz up to 50 MHz, which is really cool. Then it says here that have a 5-digit display, can measure with a high accuracy up to 0.0050 kHz and 4.5765 MHz or 11.059 MHz. Looks like it's doing programmable frequency settings. The device includes programmable add subtract frequency settings, which make it easy to measure wireless communication device such as a transceivers, which is really cool. I told you it's a handy device, costing really cheap, like £5, $4.69. We say that can be powered with the 5 volts up to 9 volts, and here it says that the crystal testing range is between 4 MHz to 48 MHz crystals. Alright, so let's see what can do. So here we go. I have my function generator here, which is set up to 8 volts peak to peak and 1 Hz, and our device, which is not yet power on. So let's power on now with my power supply set up on 5 volts. So on right now, I can see there is 5 volts over here on the power supply. This one was already turned on, and it shows 0 because the function generator is not turned on. So let's turn on the output, and instantly it gives us that there is 1 Hz over here. So you can see I put this foil on the top for the better visual, because if I remove the contrast is too high and you cannot see good the numbers. So that's why is that foil over there. So let's increase over here. So if I go 2 Hz, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30 Hz, 40 Hz, 50 Hz, 60 Hz, 70 Hz, 80 Hz, 90 Hz, 100 Hz, till here it looks like in measuring precise. So let's go 200, 300, 400 hertz, 500 hertz, 600 hertz, 700 hertz, 800 hertz, 900 hertz, 1 kilohertz. So up to 1 kilohertz looks like it's measuring precise. 2 kilohertz, 3 kilohertz, 4 kilohertz, 5 kilohertz, 6 kilohertz, 7 kilohertz, 8 kilohertz, 9 kilohertz, 10 kilohertz, 20 kilohertz. Here is start a bit of losing the precision. I can see it's fluctuating between 19.998 and 20. 30 kilohertz. Also here a bit of fluctuation I can see there, but still a bit stable. 40 kilohertz, 50 kilohertz. See already here it's losing some precision, so it's measuring 49.998. 60 kilohertz, 70 kilohertz, 80 kilohertz, 90 kilohertz, 100 kilohertz. So in 100 kilohertz is measuring 99.996. 200 kilohertz, 300 kilohertz, 400 kilohertz, 500 kilohertz, 600 kilohertz, 700 kilohertz, 800 kilohertz, 900 kilohertz, 1 megahertz. So at 1 megahertz we are already in 999.96, so it's missing like 0.05. So there it says that this was 0.005, so it's not that precise how they say over there. 2 megahertz, 3 megahertz. Oh, 3 megahertz looks like it's measuring only. Let's have a look, because maybe the amplitude needs to go more high. Yeah, I can see if the amplitude is go more high, we are more stable. Yeah, so because it doesn't have any preamplification, this device, so go straight to it, I think logic level at 5 volts RMS. So 9.5 peak to peak, we are in 4.25 RMS, something like that. So we go to 4 megahertz, 5 megahertz, 6 megahertz, 7 megahertz, 8 megahertz, 9 megahertz, 10 megahertz, 20 megahertz, 30 megahertz, and my signal generator go up to 35 megahertz, so no longer than 35. So this is what they can do. And on 35 megahertz, I'm not sure even the signal generation is operating precise. But anyway, it's working pretty good, this frequency counter. So I look around to all my components and I find out some crystals. So this one, for example, this says that is 19.6608. This device measures also crystals. So if I put this one here, I should get the measurement of the crystal, and you can see it's staying clear, 19.660, and if it's missing the next digit it will gonna say 08. Then I have two crystals over here that I don't know the value of them, so that's handy because you can discover the value. So this is 17.304. Sorry for reflections, but I don't have any other foil to adjust over here. So you can see this one is 17304. So I use the foil because look, with the foil you can't see very well due to the contrast, but with the foil you can see better the numbers, right? So let's see the other one, which value is it's gonna tell me that is, because I found this one on my components. So this one looks like the 24.646. Yeah, so this device is really cool. If you have some crystals around and is not saying the value of them, definitely with this device you can discover the value. And indeed I press the button as well, and has some kind of menu. So I can see here I have no PSL, add, where we was talking about add and subtract. So this one is add, subtract, this one is putting to 0, I believe, the frequency. This one is a table, and this one, let's say, is quit, and then no PSL again from 0. So yeah, I believe is a cool kit that anyone can build very easy, and is very handy for those they don't have enough money for a oscilloscope, and if they want to measure a frequency, that's okay. It will not show you the sine wave because you need the oscilloscope to see on the display the sine wave, but if you want to have idea which frequency, maybe a pulse with modulation has a frequency, and if you want just to know the frequency of the pulse, with this one you can measure that one. But bear in mind, you need to inject on this signal over here at least minimum 8 volts peak to peak. And if you are measuring very high frequencies, you need to have 9.5. You can see when I measure it there. So a little preamplifier on the beginning of this one can be handy as well. So yeah, let me know in the comments down below your thoughts about this device. Definitely this device is really handy. If you are interested, check the link on the description down below, because I'm gonna put the link. And it's really doing a really great job. For such £5, this device really worth that money. And if you enjoyed this video, don't forget to give me a like. And if you are interested on all the tools that I have around my working bench, if I am using daily, check also all the links on the description down below, because it will gonna show you everything what I am using, and I definitely can recommend them because are great for me and are doing a great job for me. If you are new and watching this video, don't forget to subscribe and activate also the notification bell, like that you'll be notified when I come with the new videos. And until the next one, guys, have a good day and bye bye.